In this video, let's work on the second source of variation in our model. And before that, let's have a look at this red line over here. This red line over here is showing us the average wage in our sample, which I noted to be $2,000. Why do we need this? We need this because in absence of information, so if we do not know anything about the education of an individual, the best guess, the best prediction for his wage is the average wage. So without information, I'm gonna write it here like that real quick. Without information, our best estimate for the wage of an individual, is the average wage in that specific sample. And why does this matter? Let's prove this with an example why it matters. Let's take this set of observations over here. Let's assume these are the actual wages for individuals with 5 years of education. So if we do not have information that these individuals have 5 years of education, we would predict that they earn $2,000. But because we have information that they have 5 years of education, we are predicting on our regression line, we are predicting that they should earn, let's say $1,300. We predict $1,300. So the difference that we're having between the best estimate, between the best guess, which would be literally a guess without any information, and what we're actually predicting by having the information is an improvement in our prediction, is the fact that we're able to predict a different value than the best guess. So the difference between these, let me change colors, the difference between the best guess and our prediction, so this one between the red line and the green line, this difference for this level of education is the variation that happens because we are predicting with our independent variable, with our education variable. So this is the source of variation that is explained by our variable, that is explained by our model, which contains education in it. And we would do so for all the observations that we have over here. So for other guys, let's say these ones, which have, for instance, 6 years of education, we would also take the difference between the average wage and the predicted value in our regression. So that difference over there would be another source of variation explained by the fact that they are educated for 6 years, explained by our model. And we would do so for all the cases. We take the differences between the average, between the best guess and our estimate, our regression line. And as usual, we would take the squared differences because we do not want to miss out on those differences by canceling some positive and negative differences. So we would have the sum of squared differences explained by our regression, which we usually note SSR, which is again a sum of the differences between the predicted values that we have for an individual from the average wage in the sample, from our best guess, and we take the square, so we take them to the power of 2. Now by definition, these are the two sources of variation, and they add up to the total variation in our model. So I'm gonna write it over here. They make up the total variation in our model, and the total variation in our model is equal to the sum of squared differences between the actual observations and the best guess, again to the power of 2. So intuitively, I hope this makes sense, because the best guess is the wage that we would predict without having any information, and then the actual observations that deviate from the best guess is the total variation that we have in our model. Now what does the R square show us? The R square shows us how much of the total variation in the model, what proportion of it, is explained by the regression. So by definition, R square is showing us the ratio between the sum of square differences explained by the regression relative to the sum of total square differences, the sum of square differences in the entire model. And the R square would be a proportion, it would be a percentage. And let's just give an example that the R square would be 0.7. What does that mean? Which is the same as 70%. Well, if we go over here in our model and we take a set of individuals, let's say over here, we can see that their wages are gonna differ between each other, right? There's gonna be a variation in the wages. The variation are in the results. 70% of that variation is explained by the fact that they have an education of 10 years. Their education level explains 70% of the fact that their salaries, their wages differ. The other 30% of that difference, we don't know. It happens due to the error term. It happens because some of them are more talented, some of them have better backgrounds, and so on. And that's it with the R square. I hope this makes sense, and we are done.